In this video, we're going to evaluate the integral of the square root of x squared plus 9 over x. So this is got square root in the numerator, and the radicand is the sum of squares, x squared plus 9. So that's going to suggest that we're going to have to use a substitution involving tangent. If you got the form square root of a squared minus u squared, a is constant, u generally is a function of x, you have a substitution u equal a sine theta. It's the other way, square root of u squared minus a squared. Use a substitution u equal a secant theta. Now sometimes you don't have to have the square root. As long as it's in this form, you can try this method here. And like I said, in our case, we have the square root of a sum of squares, u squared plus a squared. So we're going to use a substitution u equal to a tangent of theta. So here's a substitution then we're going to use. In this case, instead of a u, it's just a plain x. Sometimes it'll be u squared, and u could be a function of x, something like x plus 2 or 2x minus 1 or something. And the constant here, a, or a squared, in this case would be 3 squared, so a would be 3. So the substitution I'm using here is x is equal to 3 tangent of theta, which tells me then that I can rewrite this as tangent of theta equal to divided by 3, x over 3. And this is what I'm going to use to form the triangle. And then from this, dx equal to the derivative of 3 tangent theta is 3 secant squared theta d theta. Replacing the 3 tangent theta here for x in this radical, I'm going to get 3 squared would be 9, and then go to the tangent, you get tangent squared here. Again, I'm plugging the value of x here, 3 tangent theta, in for x here. I get this here, then plus the 9. Take out the 9 here, factor it out, and you get tangent squared theta plus 1. So this is one of your Pythagorean identities. This is equal to secant squared theta. So that's here. That's will go in here. And then the square root of 9 will give me a 3. So I got this 3 right here. And then this is the same thing as secant squared theta. Take the square root of that, gives me secant theta. Again, it's going to be positive because for the right triangle, I'm using an acute angle. So trigonometric values, or trig values of an acute angle, whether it's secant, tangent, or whatever, first quadrant, they're all positive. So no absolute values are needed here. So that's how we get this part right here. And for this triangle here, this is theta. And then from this here, tangent of theta is equal to x over 3. So the tangent is the opposite over the adjacent side. So that's why I got x here and 3 here. And then this side, the hypotenuse, should equal to the sum of the squares of the other two sides. So this squared here should equal to this side squared plus this side squared. Of course, gives you x squared plus 9 is equal to x squared plus 9. So now we just plug it in here. It'd be the integral. And for the numerator part, square root of x squared plus 9, that's going to be your 3 secant theta. So replace the numerator, the radical expression, square root of x squared plus 9 by 3 secant theta. And then the denominator, I'm transforming the integral now in terms of a variable theta. So I gotta get rid of the x here. So what is x? X is 3 tangent theta. So we'll have an x in the denominator about 3 tangent theta. And then for the dx, got a replacement right here. That's going to be 3 secant squared theta. So again, the radical expression in the numerator is replaced by 3 secant theta. The dx is replaced by 3 secant squared theta. The denominator x is replaced by 3 tangent theta. And I can cancel, say, this 3 here and this 3 here. Now set up the integration for this. So I'm going to do it this way then. Still have the 3 here, so I'm going to put it out here outside the integral. And then I'm going to replace this secant squared. I could change everything to sine and cosine, but let me just do it this way. This will be 1 plus tangent squared theta. That's one of your Pythagorean identities again. 1 plus tangent squared theta is equal to secant squared theta. So I'm replacing the secant squared theta by this expression here, 1 plus tangent squared theta. Get 3 out here, and I still got the secant here, theta, and then I'm dividing the tangent into this right here. So tangent theta into 1, or 1 divided by tangent theta. Because tangent and cotangent are reciprocals, I can write 1 over tangent as cotangent theta. And then tangent theta into tangent squared, that goes 1 time. So there's going to be a plus here, and I get a tangent theta. That's a d theta here. And I should have a d theta over here. This would be 3 here. This is the integral of, remember here, cotangent is cosine over sine, and secant is 1 over cosine. So let's multiply through here. I'm going to think of this as 1 over cosine, and then cotangent is cosine over sine. So the cosines cancel out, and I get 1 over sine. But I rewrite it. 1 over sine can be written as cosecant theta, because they are reciprocals. And there we got secant theta, tangent theta here. This would be plus secant theta, tangent theta, d theta. So a quick review here. We made the substitution in the numerator, in the denominator, and for the dx was 3 secant squared theta d theta right in here. There should d theta. 3 and 3 canceled, left with 1, 3, took it outside the integral here, and then brought this down here, secant theta, and then I replaced the secant squared theta by 1 plus tangent squared theta. Then I divided the tangent into the 1, and that can be written as cotangent of theta instead of 1 over tangent. And then tangent squared divided by tangent, reduced it down to tangent, and then I multiplied this out, secant theta here, and I said cosine, or cotangent is cosine over sines. Secant is 1 over cosine, so that canceled the cosine up there. Left me with 1 over sine, which is cosecant. Got it down to here. And then secant theta just multiplied here. Secant theta times tangent theta. We have that. Now we just integrate. Simple integration here. So I'm going to go up here so I don't run out of space here at the bottom. So I got a 3 out here. And then we integrate with respect to theta. I got cosecant theta. So let's do this. That's 2 integrals. So this is my first integral. The 3 multiplies the result here. So the formula for the integral of cosecant, there's 2 forms of the formula. I'm going to use this one here. It's minus the natural log. It's kind of like similar to the one involving integral of secant, except this is cosecant. And this is going to be the absolute value of cosecant of theta, and then it's plus cotangent. So again, the integral of cosecant theta is given by this formula here. So it's minus the natural log of the absolute value of cosecant of theta plus cotangent of theta. And then for this one here, the derivative of secant is secant tangent. So we know then that the integral of secant theta tangent theta is secant theta. You have plus the constant of integration. Now we're going to use the triangle to go back to the original variable. Anytime you use a substitution, once you finish your integration, in this case with respect to theta, then we go back to the original variable, which involves x. So to the triangle then, I'm going to multiply it here by 3. So the 3 multiplies to minus 1 here. So I'll put it right here, minus 3, and then it's the natural log. Now let's see the value of these expressions contained in the absolute value. So cosecant of theta is the hypotenuse, square root of x squared plus 9, over the opposite. So this would just be square root of x squared plus 9. Again, from the triangle, hypotenuse, square root of x squared plus 9, over the opposite side, which is x. And then it's plus cotangent. Now, cotangent is the adjacent over the opposite, just opposite of tangent, which is x over 3. So cotangent of theta, 3 over x. Then it's plus secant of theta. Secant of theta is the hypotenuse, square root of x squared plus 9 over the adjacent side, just the opposite of cosine. So that would be the square root of x squared plus 9 over 3. Secant, square root of x squared plus 9 over 3. But remember, I'm multiplying by 3 here. So I'll just cancel the denominator. It'll leave me the square root of x squared plus 9 plus the constant of integration. So the final answer then is minus 3 natural log of the absolute value of the square root of x squared plus 9 over x plus 3 over x plus the square root of x squared plus 9 over 3. But remember, multiplied by 3. So that got cancelled out. That's the final answer. Thanks for watching. We'll see you next time.